All right, here we go. Lesson 20 practice problems. Also got this card as a gift from my teaching assistant. This is Shaquille O'Neal. I would probably put him as my starting center on the all-time greatest list. He was so much fun to watch. He was Kobe's partner in crime for 3 titles. When the Lakers got their three-peat, it was so fun to watch. Kobe Bryant, Shaq, Robert Horry, Derek Fisher, Brian Shaw. Gosh, I'm forgetting a ton of guys. But anyways, the Lakers in the early 2000s were awesome. And then Shaq won another title with Dwayne Wade in, I think, 2006. Huge personality, dominant force. So anyway, Shaquille O'Neal. All right, here we go. Lesson 20, practice problems. Priya, I bet if the alternate interior angles are congruent, then the lines will have to be parallel. Okay. So Priya's making a bet. If alternate interior angles are congruent, then the lines have to be parallel. Okay. Han, really? We know if the lines are parallel, then the alternate interior angles are congruent. But I didn't know that it works both ways. Priya, well, I think so. What if angle ABC and angle BCJ are both 40 degrees? If I draw a line perpendicular to line AI through point B, I get this triangle. Angle CBX would be 50 degrees because 40 plus 50 equals 90. 40 plus 50 equals 90. Actually, 40 plus 50 equals 90. And because the angles of a triangle sum to 180 degrees, angle CXB is 90 degrees. It's also a right angle, okay? This one right here. Oh, Han. Oh, then line AI and line GJ are both perpendicular to the same line. That's how we constructed parallel lines, by making them both perpendicular to the same line. So lines AI and GJ must be parallel. Label the diagram based on Priya and Han's conversation. Okay. I think I can do that. All right. So Priya, I bet if the alternate interior angles are congruent, these two, then the lines will have to be parallel. These two. That's her bet. Han says, really? We know if the lines are parallel, then the alternate interior angles are congruent, but I didn't know it works both ways. Okay, so they're going to discover this fact, that if these two angles are congruent, then that means these two lines are parallel, because they're cut by a transversal, and alternate interior angles assumes that these lines are parallel. Okay, well, I think so. What if angle ABC and BCJ, so these two angles, are both 40 degrees? If I draw a line perpendicular to AI, so perpendicular to AI through point B, so there's the line perpendicular to AI that goes through B. So this line goes perpendicular to AI and it passes through B. I get this triangle, this one right here. Okay. Angle CBX, so right here, would be 50 degrees. because 40 plus 50 equals 90. And because the angles of a triangle must sum to 180 degrees, angle CXB is 90 degrees. It's also a right angle. Oh, then line AI and GC are both perpendicular to the same line, right? 90 degrees. So lines AI and GJ must be parallel. Wow, okay, we did it. Is there something special about 40 degrees? Will any two lines cut by a transversal with congruent alternate interior angles be parallel? Is there something special about 40 degrees? No. This could have been any number as long as they're the same. Will any two lines cut by a transversal, there's your transversal, with congruent alternate interior angles be parallel? Yes. So your answers to these are no. Angle ABC and angle BCX could have been any measure less than 90, as long as they are congruent. That would be my answer to the first part. And then the second part, will any two lines cut by a transversal with congruent alternate interior angles be parallel? Yes. If a transversal across two lines results in congruent alternate interior angles, then the lines are parallel. What a first problem. Wow. Okay. One down. 8 minutes in, no big deal. All right, number 2, prove lines AI and GJ are parallel. Okay, so the goal on this is to prove that this is 90 degrees. Because then we have a line perpendicular to two lines. And if there's a line perpendicular to both lines, then that means these lines are parallel. Okay, so first thing you need to know is this is also A degrees. So you can say that angle ABC, so angle ABC, if you want to put the measure of angle ABC, equals A degrees, because this is what you need to know. Vertical angles are congruent. Same measure. What are vertical angles? Well, I'll show you. Hopefully you see the V, oops. You see the V and A right here? vertical angles are congruent. That means that this is congruent to this, and this is congruent to this. Vertical angles are congruent. Okay, so you need to know that. All right, now, you know that a straight line has 180 degrees, right? You also know that this is 90, meaning that this and this have to equal 90. So you can envision this angle as 90 minus A, right? Because the whole thing is 90, and you have to subtract A to get this angle right here. So you can say that one's 90 minus A. Now this is a triangle right here. And there's something called the triangle sum theorem. That states that every triangle has 3 angles. I'm going to color this one in. So every single triangle has 3 angles, and they all add up to 180 degrees. So that you can then say that A, that one, plus that one, 90 minus A, plus this one, which we'll just call X for now, plus X will equal 180. Fair? Okay. Let's just rewrite this. A plus 90 minus A plus X equals 180. A minus A is nothing. So you're going to get 90 plus X equals 180. Subtract 90 to both sides. X equals 90. That means this is 90. And that means this is 90. So we use the triangle sum theorem to prove that this was 90 degrees. So X is 90 degrees. Since that's 90, then so is that. And then you now know that this line, which we're calling BX, so BX, is perpendicular to AI, and it's also perpendicular to GJ. So another concept you need to know. If a line is perpendicular to 2 lines, then those 2 lines are parallel. Boom. So you need to know this. If a line is perpendicular to 2 lines, then those 2 lines are parallel. So AI is parallel to GJ. There's a proof for you. Fun stuff, huh? You gotta go slow, use logic, try not to skip steps. Go slow, use your logic, try not to skip steps, and provide reasons for your claims. You can't just say something is true. You gotta provide evidence why. And like quick refresh, vertical angles are congruent, so that was A. Because this was 90, this is 90 minus A, because the whole thing, this other whole thing is 90. Then we used the triangle sum theorem down here. That plus that plus that has to equal 180. Figured out that x equals 90. Therefore, this equals 90. And finally, we applied this concept. If a line is perpendicular to two lines, then those two lines are parallel. All right, here we go. What is the measure of angle ABE? Gosh, that's a piece of cake. You just need to know this concept up here. That vertical angles are congruent. All right, there's number 3. Let's go to number 4. Lines AB, and BC are perpendicular, meaning the whole thing is 90, right? So you automatically know angle ABC equals 90 degrees, right? So the dashed rays, there's 2 of them, bisect angles ABD. So this angle, so this dashed line bisects ABD, meaning that this angle has the same measure as this angle. So we'll just call it like X degrees. Okay? That means this dashed line bisects CBD, the whole thing here. Meaning that each of these is the same. So we've got an X, a Y, and a Y. And since ABC is a right angle because the two lines are perpendicular, you can say X plus Y also equals 90. So we're halfway there. Then you can say 2x plus 2y equals 90. Then you can say 2x plus y equals 90. We're just pulling the 2's out. Then divide by 2. These 2's are out of here. You're left with x plus y equals 90 divided by 2, which equals 45 degrees. And then they say explain why the measure of angle EBF, angle EBF equals x plus y, EBF equals x plus y. Why is EBF 45 degrees? Well, because x plus y equals 45 degrees. We just proved that over here. X plus y equals 45. So therefore, if these are the same on the right side, then you can say these are the same on the left side. And you can end it at angle angle EBF equals 45 degrees. There you go. Cool problem. Okay, number 5. Identify a figure that is not... Oh, you got my coffee. Thank you.
It's not poured in yet.
Oh, you're gonna add the protein? Nice. Let me show you folks what we're doing here. Let me see this. I'll give it right back. I do a coffee and then add one of these cafe lattes. All right.
With the Grinch cup.
With the Grinch mug. All right, so what you're gonna do on this one, you gotta find a figure that's not the image of quadrilateral ABCD. This one that I'm shading in while Claire is making me a coffee. Nice job, Claire Bear. Alright, we gotta figure out an image that's not, or we gotta figure out which one of these is not the image of ABCD, which I'm shading in for you, so we all know what we're talking about here.
Can I say hi?
Say hi from there, yeah.
Hello.
Okay. Thanks, Claire. Here's my Grinch mug.
Don't spill it.
Miss Norman got me this Grinch mug. Let's see if we can see it. There he is, kind of. Oh, I spilled it. Oh, well.
Do you want me to get napkins?
Uh-huh.
Yep. I found it.
Oh, well. Took a risk.
Can you print another one?
Yes, I actually have another one. Sweet. So look at that. Got another one. All right. Here we are again. So where were we? A, B, C, D.
Hello, go.
I think I got it all. Thank you, thank you, thank you. Okay, so Claire, you might like this problem. Had a coffee fiasco mid-problem. All right, so A. Claire, out of there. Come on, I gotta concentrate. I gotta
watching it.
concentrate. Yeah, well. So you got A, B, C, and D. Okay. Then you gotta connect the dots. Might as well go in order. B to C. Claire, would you be okay with going to the climbing gym tonight as opposed to this today?
Yeah.
Okay, cool. All right, so you got A, B, C, D right there. All right, just for fun, I'm gonna shade it in. Why not? All right.
Dad, can I trace something?
Yeah. What are you gonna trace?
A ghost.
Go for it. Getting all Halloween. Getting some. Oh, you gonna do one of the painted rocks?
Maybe.
Should. Gotta do that whole path. Okay, so here's A, B, C, D. All right. We gotta figure out which one of these is not the image of A, B, C, D after a sequence of transformations. Explain how you know. All right. Well, I'm just gonna figure out which of these real quick don't match the same shape. That's the easiest way to do this one. That one's good. That one's good. I think I know which one it is. That one's good. Okay, I'm pretty sure it's this one.
Dad, do you have any regular pencils?
Yeah, it's this one for sure. Gotta be this one. Yeah, you could do all the moves and write a 2-page paper on why this green one, this green quadrilateral is not a sequence of transformations of A, B, C, D. But here's a much, much easier explanation. So I know that quadrilateral MJDA, let's see, ADJM. So quadrilateral ADJM is not congruent to quadrilateral Just take pride in your work. A, B, C, D. So I know quadrilateral ADGM, JM is not congruent to quadrilateral ABCD because they are not the same size and shape. So congruence implies same size and shape. They're not. I mean, look at it. ABCD is not the same size and shape as ADGM because ADGJM is not congruent to ABCD. There is no sequence of transformations that will take one to the other. Boom. Now, every single one of these real quick. See how fast I can do it. This one looks to be a translation reflection. Nope. Let's see. Reflection. Wait, hang on. Okay, A to N. Nope. What is this one? Oh no, I'm choking. Just kidding. The translation, reflection, rotation, reflection. Okay, this one, let's see. A, B, let me see. That's not gonna do it. Oh wait, this one's just easy. This one's just a rotation. Okay, let's look at this one. A to F. Reflect over this line. Be here. Rotate. Reflect. Okay. This one I think is a reflection. Another reflection? No. Alright, let me see. I know. What if we go like this? Translate.
I have a question for you, Dad.
Yeah, hang on. Choking under pressure here. How about reflect over AD? Translate. Hey, I finally got it. Whew. Survived another one. Anyways, all the other ones, so 1, 2, 3, and 4, there's a series or sequence of transformations from ABCD to 1 to 2 to 3 and to 4. This is the only one where it's not possible. Whew. Tough problem. All right, number 6. Here we go.
Before you start it.
Yeah, let's hear your question. Make sure it's okay for the video.
It is. Is teaching your favorite job that you've done so far?
Good question. Yes. It's such a challenge, and it's so much fun. All right, here we go. A, B, C, D is congruent to A prime, B prime, C prime, D prime. Ooh, much easier problem. Sweet. Describe a sequence of rigid motions that takes A to A prime, B to B prime, C to C prime, and D to D prime. So easiest way on this is to trace. Tracing is your friend in geometry. It's one of the reasons I trace most of my drawings.
I'm gonna have to steal the pen out of this. Then I'll put it right back
Okay, so you just trace A, B, C, D. Okay. Now, describe these moves. Was that a translation, rotation, or a reflection? Gotta describe the directed line segment. Is that a rotation, reflection, or translation? Gotta describe the center, the direction, degrees, or name the angle. If you need a name for the angle, look at it. We're going to there. You can name that angle right there. Okay, boom, there you go. There was a demonstration with patty paper. Now you have to describe what I just did. So you gotta write the two moves. So you'd be like, 1 was a translation, 2 was a rotation. What was the DLS? What was the center, direction, degrees? Or angle name? Or until point blank aligns with point blank. Couple ways to describe this third one, but you gotta nail what the center, direction, degrees are. So center, direction, it's either clockwise or counterclockwise. Center is gonna be a point, degrees or angle. So degrees or angle, or until point blank aligns with point blank. You know what the TR is. What's the directed line segment? One more time. What's this directed line segment? What do you think? What's the center? What's the center of rotation? What's the direction? What's the degrees or angle name? Or until point blank aligns with point blank. Okay, anyways. Number 7, triangle ABC. Is congruent to triangle A prime, B prime, C prime. Okay, that means I can trace this one on patty paper and somehow make it go to this one. That's what that means. It also means it's the same size, same shape. The side lengths of corresponding sides will be the same. The corresponding angles will have the same measure. All right, that means this is a pre-image, this is the image. Anyway, ABC is congruent to A prime, B prime, C prime. Got it. Describe a sequence of rigid motions that takes A to A prime, B to B prime, and C to C prime. Best bet on this is to trace A, B, C. So you got a nice copy of ABC. Use this tracing paper. Now I know A is going to end on A prime, so why don't we do this move? What's that called? Translation, rotation, or reflection. Now I know we got to get B to line up with B prime. So what's this move called? Is this a rotation, reflection, or translation? Which direction did we go? So watch this. What's the center? What's the direction? Is this clockwise or counterclockwise? What's the angle? I'd accept B, A prime, B prime. That would work. Or B, A, B prime. I would know what you mean. Anyways, you got to describe the sequence. That one, to me, was a two-stepper. So write out the 2 steps. 1, 2. All right, you need to get the DLS, and you need 3 things. Okay. 8, we're gonna skip. We didn't cover angles of rotation that create symmetry, although that's a cool concept. So you can skip both of these. Gosh, this would have been a great drawing.
Which would have?
3 line segments, AB, BC, and CD, form the letter N. I like this one. Let's rotate the letter N clockwise around the midpoint of segment BC by 180 degrees. Describe the result. Now, how could you get the midpoint of BC? Here's the easiest way. Most math teachers would hate me for this. Measure it 5.5 centimeters. 5.5 divided by 2 is 2.75. There's the midpoint of BC. Since we're going A, B, C, D, let's just call this, let's call it M for midpoint. Now with your patty paper, you want to start using the edges or like the corners so that you save it and you only need to use 1 piece. All right, here we go. A, B, C, and D, label them. A, B, C, D. We'll capture M while we're at it. A couple other ways to find that midpoint also. As an FYI, you could have done the perpendicular bisector of line segment BC to find it, but in the interest of time, we're at 38 minutes. I just measured it. All right, so we are going to rotate the letter N clockwise around the midpoint of BC by 180 degrees. Now, what that means is that MB, if I rotate this clockwise 180 degrees, you know MB is going to land on MC. So watch this. Center, midpoint, 180 degrees. MB is going to land on where C is, right there. So that's going to be a 180 degree rotation. Right there, around the midpoint of BC. Describe the result. You see the letters are flipped, right? How about this for a description? Same letter, same shape, still an N. Cool. 40 minutes. Go Shaq. Best center of all time.
Can you say hi?
You can say bye.
Bye bye.